Oh, I saw this in my recommended. And it's just...
Brainf is a pro.
You saw the thumbnail. Let me just here's the thumbnail. What is this? Yeah. Also, it's a Rust programming video. It's a Rust programming video. I don't know what this video is. I just watched the first 5 seconds. That's vidIQ.
Brainf is a programming language invented in 1993 by Arthur Muller and contradicting to popular
I think I'm too old for this video.
believes it was not designed to conduct sexual intercourse with one's reasoning faculty. Instead, it was designed for the world's smallest compiler.
Yeah, brainfuck is a weird fucking language. It's... Again, it's the name is very apt.
What's the point of making a high-level language when the source code is less readable than the output?
Well, it allows for a smaller compiler.
I know, but...
Small compiler!
True!
What even is the syntax of this language?
Great question. And why don't we learn that by writing an interpreter in Rust? Let's start by creating the function
I think I'm too fucking old for this. Jesus Christ. There's too much happening.
which takes a vector of bytes and returns a result type.
Uh-huh.
Next, let's create some variables for bookkeeping.
I don't know enough Rust to know what the
PC
fuck that
represents
means.
a program counter which points to the current code that's
Sure.
being executed. Cells represents a memory region of 30 kilobytes.
Okay.
CC represents a cell counter which points to the memory cell that our program can have direct access to.
Okay.
It's kinda similar to a pointer, but not really. Hopefully it will make more sense later. With that out of the way, it's time to create our main
Has the video just
execution.
like gone from like Zoomer brain rot into like actually educational?
The most basic logic is obviously move to the next operation, which can be implemented by increasing the program counter by 1. This is also how you implement no-op.
Why don't you go insert 44 no operation comments?
Brainfuck is more than no-op, so let's implement some real
Yeah, I'm sure you can go to like I'm sure if you look up get YouTube thumbnail extension, you'll find something.
operations as well. The left angle brackets moves the cell counter 1 step to the left.
Okay.
The right angle brackets does the same, but to the right. The plus sign increases the value of the current cell, i.e. where the cell counter points to, by 1. Think of it as dereferencing a pointer and increase its value. The minus sign does a similar thing, but in the opposite way. The square brackets are not as trivial as the previous operations. They create something similar to a C-style while loop, where it keeps looping until the current cell reaches 0. We can implement this by creating something similar to, well, a while loop. For the left square bracket, we can check if the current cell is 0. If so, we can jump to the operation after the scope of this bracket. For the right square bracket, we can check if the current cell is not 0. If not, we can jump back. By the way, this whole scope pairing thing is impossible to implement with a regular expression because regular expressions are not Turing complete.
Regex is the root of all evil something something.
You're actually so real for that.
What is
The
this
last
video?
two operations are not as complicated.
Like, I looked at this channel, right? Okay, let me show you something. This is the one video on this channel. This is the one video on this channel. I don't even know how this got recommended to me. It has 4,500 views. I don't understand what my YouTube recommendations are these days.
There's standard out and standard in. The period prints the value in the current cell as an ASCII character.
Okay.
The comma reads 1 byte from the standard in and writes it to the current cell. And voila! A fully functional brain interpreter. Well, functional as in it works.
Yeah, I know.
Not
You don't
programming
really
paradigm.
need to explain. To be honest, I am still a bit confused about how brain works.
Yeah, true. I am as well.
Let's run some Brainf programs then. I got these shirts for 20 bucks and the Brainf program on it prints out every single ASCII character from 1 to 255. I think the program is pretty self-explanatory. It first increases the value by 1 so that it will enter the loop.
Okay.
And during each cycle, the value in the cell is printed and then increased by 1. After it overflows back to 0, the loop breaks.
Okay. Okay, right.
You can also shift the pure and the plus to print from 2 to 255.
But I doubt if you can write actually useful program with that.
Brainf can be more ergonomic than you might expect. A cat is a type of program that redirects its input to the output, not to be confused with the other type of cats, which are evil and eat babies. Anyway, here's one possible cat's implementation in Brainf. Notice that because there isn't a standard way to handle strings in Brainf, this particular implementation requires the input to end with a null terminator.
But you know what I mean, right? There isn't even an easy way to get numbers into the memory.
It's alright, you can just use as many adds as you want. For larger numbers, you can also use this pattern to do multiplication.
Knock it off. Enemy reference is still cringe.
My point still stands, it's
I don't think I'm gonna understand how this language worked by the end of this video.
Turing complete. It does everything that your computer can do, including greeting your mom.
I don't know about that.
Oh, come on! At least it's better than JavaScript. Look, here's the speed comparison of Hello World between...
It's faster, therefore it's better. There are actually people that try to make this as like a real argument and not a shitpost.
Node.js and my crappy Brainf interpreter. Just look how fast it goes. I need to see a composable, isomorphic, declarative, hyperscalable, serverless, full-stack Brainf framework trending on Hacker News right now.
No one's gonna raw dog
Anyway, the current implementation of the interpreter is not very Sigma. It's some no aura level 1 no white beta get like Biba.
You know that wasn't funny, right?
So let's make some changes. For starters, we can create an enum. We'll use this enum to represent our Brainf program. Now, instead of going through the raw source code directly, we can go through the same thing but in a different format. While this change has very little impact on performance, it does make the implementation more flexible. Say, if I want to swap up a symbol of Brainf to create my own programming language, I would only need to replace the parser instead of the entire runtime. And more relevant to the topic of this video, it also makes performance optimization easier to implement. I know someone has to be yelling this entire time. And yes, the loop handling is pretty bad. We can add a user...
I don't think anybody's noticing that with the rest of what's going on.
As filled to the left and the right brackets. Then during the parsing process, we can use a stack to keep track of the indices and store the jumping locations. Now, instead of scanning for the matching brackets every time, we can just jump directly to the target. For most of the Brainf programs, this improves the performance significantly. Another straightforward optimization involves consecutive symbols. It should be obvious that consecutive adds and subtracts can be collapsed into a single operation. Just like the brackets, we can add a new UH field to our adds and subtract operations to store the total value change. Similarly, we can optimize the consecutive move left and move right operations by collapsing them and store the total pointer movement with a U-size field. And thanks to those changes, the performance is even better now.
I think we have run out of obvious optimizations.
Actually, not quite. Another low-hanging fruit is this pattern, which sets the current cell to 0. It's somewhat similar to this operator in most of the C-based languages, which is to say that it's not really an operator or syntactic sugar, but more of a happy little accident of language design. Since we already know the results of this particular loop, we can just turn it into a new operation, which directly sets the current cell to 0 without actually performing the loop. And depends on the workflow, sometimes it helps a little, sometimes it helps a lot. For most modern languages, what you understand conceptually about the execution flow isn't typically how it works, and that is why you should always benchmark your code.
I just want to pause this video at every single point that anything else besides code is shown and just analyze what the fuck is going on here.
But can we go faster than this?
Alright, let's say hypothetically you want to optimize even more, and for the sake of argument, let's assume you have skill issue as well. And consider the fact that you're not a white man like Terry, then I believe that you... Everything here.
I don't know if I can trust her if she's gonna start showing Terry Davis.
You agree with me when I say in this hypothetical scenario, you should use someone else's compiler. Am I not correct?
I guess you are correct. but it really could have been just one sentence.
As a wise predator once said, reinventing the wheel is bad. Finding out logics that can be optimized away is a whole field of data fact study that most people are just not very familiar with. So for the key scoping mass, it's probably better to use the library instead. The idea of taking advantage of other existing compiling infrastructure is nothing new. If you've done Unity development before, you might know the build option called IL2CPP, which stands for Intermediate Language to C++. And as the name suggested, it will convert your C# code to C++ and then compile your code with the C++ compiler instead of using the modal runtime, taking advantage of the usually better ahead of the time optimization and smaller bundle size at the cost of some compatibility. But there's no feature to lose in Brainf, so why don't we compile Brainf to C and see what will happen?
This pun is such a linguistic disaster. It just set humanity back 50 years.
It's not intentional. It's trivial to transpile Brainf to C, so let's do it. And if you try to compile the C code and run it, you will realize the performance is worse. To investigate why, we can use ZA ASA glowware to inspect the actual code that's been generated. And as you can see, most of the operations are not optimized at all, and that's why it's so slow.
Yeah, obviously. You set the optimization level too low.
That's true, but it's a good reminder that just because the program is running natively, that alone doesn't make it always faster than the VM. However, just as you said, we can improve the performance quite a lot by simply changing the optimization level. It is also helpful to compare different compilers. For this particular program, Clan is slightly faster than GCC.
For the love of God, can you please stop making the bars move?
No. Nevertheless, there are times when fast iteration speed is required, and an optimized binary might be too slow to generate, which can result in...
No.
What?
You can't say it.
Yes, I'm gonna say it.
You can just...
Bad developer experience.
No!
I promise you that there's a perfectly valid
okay.
reason for me to make all of my animation in TypeScript, even though that does mean that I effectively have to implement the interpreter twice. So how about we combine the fast iteration speed of an interpreter with the performance benefits of running native code for Brainf, and that's where JIT comes into play.
What is JIT exactly?
It's a JIT, or just-in-time compilation, is a technique where the code is compiled and optimized just in time for execution. On a side note, one of the biggest differences between Brainf and your computer is their architecture. Brainf uses Howard architecture where the code and the states are separated, whereas your computer is most likely using the von Neumann architecture, which lacks such a separation. And what we're going to do today is only possible thanks to that. That being said, despite how people like to yap about the difference, it's kind of a nothing burger, similar to the RISC versus CISC debate. But anyway, back to JIT. To implement it, instead of interpret the program directly after parsing, we need to add a step to compile the parsed value into actual machine code. For this project, I will be using grades for CodeGen, because I don't want raw dog bits and bytes, and also CISC sucks.
Too much work!
And now we can write some boilerplates. And more boilerplates. These three registers are not chosen at random though. RCX and RDX are registers for the first two arguments in the Win64 calling convention, and REX is conventionally the return value.
But weren't those registers also chosen somewhat arbitrarily when designing the calling convention?
Yeah, just like how your mom was chosen arbitrarily when she picked your dad.
What is your problem?
For more complicated languages, we may want to design an actual call stack, but Brainf is so simple that we only need just one stack allocation. To allocate it, we can subtract the RSP, aka the stack pointer, by the amount of memory we need. You might be wondering why I allocated 24 bytes when I only need 16 bytes. That was purely for stack alignment. And the truth is, if we just stopped using high-level languages like C, it would be entirely avoidable. It probably won't come as a surprise that the assembly for most operations is more or less the same as the original interpreter, with the major difference being the syscall handling. Instead of calling directly, we will create a struct to handle it. For this particular usage, it is important to specify the calling convention as Win64, and for simplicity, I made all functions take the same argument. After that, we can create another macro to make function calls. We need to save RDX in the caller stack, and after calling the subroutine, we need to restore RCX and RDX because both are volatile for obvious reasons. Back in the CodeGen, we can use this macro to call
very
the
obvious.
function. Now that the logic part is done, we can add some checks and an epilogue, then return the buffer and the offset. In the run function, we initialize the required data structures, cast the generated buffer to a function pointer, and execute the function. The result is near C performance with much less compilation cost. Oh wait, I forgot, it's unsafe. You can't look at it.
Speaking of safety,
I am lost.
There's no bound check at all.
I could add bound checks, but it would make the performance worse. Memory safety is a more nuanced topic than what many people want you to believe. Even the white
Oh, just trash him. Lovely.
Else go back and forth on that. Not to mention that out-of-bound memory access behavior is undefined in Brainf anyway. Yes, like any well-respected language, Brainf has many undefined behaviors. Even the memory size itself is not well-defined. 30 kilobytes is just the recommended amount of memory, and you can often see people allocate different amounts of memory. The size of the cells is also debated.
Do I like
the original Brainf
I
was
do,
created
but
for a
he's very
system
easy
that
to make
only
fun of.
supported ASCII, and 1 byte was enough to represent all supported characters. However, modern systems often use more.
It's fine when he stays in his lane. When he starts talking about things that are not low-level development, he starts saying really stupid things.
Than 1 byte to encode a single character. Therefore, many argue that the cell size should be updated accordingly. Now, you probably know way too much about brainfuck than necessary. Hopefully, the next time you see brainfuck in the wild, you will be able to say,
"That's brainfuck. I recognize that."
I don't know if I learned anything. My brain is very fucked. Yup.